Hey everybody, welcome back. So today we want to talk about arc length, and our goal is to find the length of the curve defined by y equals 2/3 x to the 3/2 minus 1/2 x to the 1/2, and specifically from x equals 1 to x equals 4. So first, we're going to need to recall the arc length formula. And of course, the assumption is that the curve that's defined by the function is continuous on the interval, right? So that's important. So length is equal to the integral from a to b of the square root of 1 plus the derivative quantity squared dx. Okay, so it looks like to set this thing up, we need bounds, and that's fine, right? We're going to be integrating from 1 to 4, and we're going to need to start off by taking the derivative of this. Okay, so for us, we've got the integral from 1 to 4. I've got 1 plus, and now, yeah, it looks like I want to carefully take the derivative. So I'm going to take the derivative here. It looks like power rule. So this product will be 1 and then drop the power. So that looks like x to the 1/2. Now here, when I take the product, so that looks like minus 1/4 and then drop the power by 1. So that's going to give me x to the minus 1/2 power. And that quantity is squared. Okay, so there's my setup. As always, I'm going to double check. That seems fine. Okay, so that seems good. So I need to square a binomial, so I want to recall the following. Okay, so I want to recall that the quantity a plus b squared, that's exactly a squared, plus 2ab, don't forget that 2ab, plus b squared. Okay, so let's carry that out. So I've got this 1 from before, so that seems fine. And so now, so I need a squared. Well, if I square this, think about adding exponents when you multiply this to itself. So that's going to be x to the first, right? So this times itself. I won't do this for each of the terms, but just to note. Okay. Okay, so yeah, that's a squared. So now I want to multiply a and b and then double that product, right? So double the product of the inside. So the product of these two would be minus 1/4, and then double that for minus 1/2. So it's this times this, but doubled. And then I need b squared. Okay, so hopefully that went well. The next thing we notice are these like terms right here. We're just going to combine them. We'll end up calling that plus 1/2. So after we combine those, our next goal is to figure out how we can legally sort of break free of the square root. Because we know we can't take square roots over pluses or minuses. So how do we break free? Okay, well, let's try factoring this. That might lead someplace fruitful. And let's see. Okay. So we've got the integral from 1 to 4. And we said we want to try factoring the inside. Okay, so mentally I'm just thinking about taking the square root of this. So that would be x to the 1/2. and then times itself would give me back the x to the first. So that seems good. Now I've got my eye on this last term here. And if I take the square root of this term, that's going to give me, it looks like 1/4 x to the negative 1/4. I'm sorry, x to the negative 1/2 rather. So that's 1/4 x to the negative 1/2. And so now the big question is, well, do we actually recover that 1/2 that's in the middle? Let's find out. Remember, the first term comes from the product of the firsts. The middle term comes from the product of the outers plus the product of the inners. And this comes from the product of the last. Okay, so yeah, just check. Is this product give us x? Yep, we're all set there. Now we want to do this product plus this product and see if it gives us a half. So that's going to be 1/4 plus 1/4. So we do recover that 1/2, so that's good. So our factorization seems good, and this product, of course, is 1/16 x to the minus 1. Now you can see why this is so powerful, because it's going to allow me to rewrite this in the following way, and we'll be able to break free of the square root. And since x is positive on this interval, I'm not going to need an absolute value. So that's really nice. Okay, so the square and the square root cancel. X is positive on this interval, so we have the following. And so you can see the worst is it's over, right? This is all good now because this is just power rule. So we're happy. Just power rule. Okay, so by the power rule, I need to increase the power by 1. And then divide by that new power. Well, if I divide by 3/2, that's the same as multiplying by 2/3. Okay, so power rule. So increase the power by 1. And if I divide by 1/2, that's the same as multiplying by 2. And we need to evaluate that on the interval 1, 4. So I want to rewrite this algebraically before I compute. I can just make life a little bit easier. Now for the cube, you can put that there or there. Either is fine. Okay, great. So now we're going to plug in 4, just using the fundamental theorem of calculus. And then, of course, subtract, evaluate at 1. All right, let's see what we have here. So the square root of 4 is 2, and 2 cubed is 8. And 8 times 2 gives me 16. So that first term there will be 16/3. And so this will be 1/2 of 2, which is 1. Now this minus, of course, will go to both terms here. So that's going to be minus 2/3. Looks like minus 1/2. Okay, so that's going to be, let's see here. So 16 minus 2 is 14, so that's 14/3. And then 1 minus 1/2 is, well, plus 1/2. And so I'm going to use this to add my fractions. So I'm going to say recall a over b plus c over d, so of course assume the denominators are non-zero, is equal to this product AD plus this product BC over this product, BD. So this product is 28 plus this product is 3 over this product is 6. And that gives me 31 over 6. And that's the length of my curve.